Alright, it's Sunday, July 8th, update number 4. Here is Victor. Victor, say hi.
Hi.
Okay, he said hi. So, the robot looks a little bit different. Our drive has remained the same. I haven't bothered to fix it because it was too much effort. I just want to get a working robot right now. We have a lift on here now, and we've also got a flywheel. So let's talk, well, flywheel, the back part hasn't been built yet, but that's fine. So the first thing first, the lift is currently a reverse double 4-bar. That's going to be changed to reverse double 4 to 6-bar. If I can get a 6-bar to fit within the space, just to give me a bit more height. So the idea is that when you're all the way down, we have whatever passive claw we have here, right? And it's going to be mounted on like these rail type things. And then as the lift goes up, we have the claw slide up along these rails to this topmost point. And if we're measuring that point, that's, I think, just above 36 inches. So if we give it a little bit more height with the reverse double 6-bar, it should be okay. Victor, hush. Here's the bending on the side. So we're using 4 points just because it worked the best. No particular reason. These are 84 tooth gears. Right now everything's cantilevered. We're going to put in a second lift tower here just so that it's not cantilevered, because right now there's a lot of friction. And what's happening here is the 2-inch screw isn't actually long enough to go all the way through from one side all the way to this other side. So we have a little bit of one section C channel here where the screw is going through, like it is on the bottom over here. And then from there, it's just standoffs into this other C channel. So really what's happening is it's going through this joint, which is then attached to here. Anyways, the lift is light enough right now that it works. If it gets heavier and doesn't work, we'll change it and we'll fix it. We'll probably end up just putting an axle through there instead. Whatever. On the bottom is just, you've got your 2-inch screw going through there, all the way out to the other side with a little bit of space or lots of Teflon on it. And then you've got this gear attached to this C channel. On the bottom is just lift towers. A pretty standard and simple setup. We're actually running low on half-inch screws, so we just have these holes blank for now. Across the back, we've got one brace going across. We're going to put a second one across the top as soon as we figure out the motor situation here, because we're low on metal, which is being used over here. So right now what's happening is the motor is driving one shaft on one side, which is going into a 12-tooth pinion. Why is my window there? A 12-tooth pinion and then an 84-tooth gear. And then it's being linked to the other side by just 36-tooth gears, a shaft, and then cross, and it works okay. The right side, left side technically, is a little bit slower than the right, but it's stable enough so far. Hopefully if we put another brace across, it'll be fine, and then we can just move the motor all the way out to one side and run a shaft all the way across, like 92 Dynex style. So that's really it for our entire lift. Nameplate's up top because obviously we have to do that. Brace across the center, one vise, and then here we just have our typical standoff. So this is a screw going through a shaft collar into there. It doesn't actually touch the chain, so we're fine. And then this is a large 2 standoffs linked together going into here, and that just gives it a little bit more stability so it doesn't shake around as much, because we were having an issue where this was swaying back and forth a lot. And then this is screwed in, the towers are screwed in. So we've got our elevated base, nylon, and then we've got our 3-wide in the center, and then we've got another one section of 2-wide. And the towers go almost all the way to the bottom of the 3-wide, where they're screwed in, and then we're using bearings on one side just because it helps to keep it a little bit more stable, because if you're not using bearings, you gotta get it tight, and then it slips and slides a lot because screws don't actually fit into the holes really nicely. So that's this part of the robot back. And there was originally at the front of the robot a large piece of 2-wide C channel going across. That's been changed to 3-wide, and it's going across the center. The reason why we're using 3-wide is that because underneath here in the center we've got a bearing screw that's holding a bearing on the other side in place, and I really didn't want to have to undo everything to move that one screw until the next rebuild. So we just put 3-wide across and then put bearings on everything to elevate it. And also for structural rigidity, but also just basically to elevate it above, I'll show you on this side, above the chain and above the C channel. So that way the C channel and the chain aren't going to be touching this 3-wide, so you can see it clears. and so does the gear. The gear actually does clear, so we should be able to drive around and not have this piece of C-channel get absolutely destroyed. Now onto the front of our robot, which is the flywheel part. We're doing two high-speed motors geared 25 to 1. The reason why we've got the two motors separated is because I couldn't actually get the motors to be centered here or centered back here without interfering with the lift, because the lift actually goes down right about to the edge of this, or the center line of this 3 wide C-channel. So that was something that we couldn't do. So we just put on the edges, and we put this little gearing on the side. So this is actually 60 tooth into 12 tooth and 60 into 12. Same as before, except this time we're not using high strength gears. We're just using our normal low strength gears because I've heard that they work just as well. And then of course these are feeding into the flywheel, which is going all the way across. These are chassis rails, and we're using bearings again to help keep it a little bit more stable. Bearing here, we're using a push peg here and here because we ran out of, or we didn't run out, but we're really low on the 0.5-inch screws. So we're using push pegs just for now, along with our normal screws, right? So that goes into this tower here. So this is 4 sections long, and it screws into the base here. No bearings this time, because otherwise this shaft wouldn't be long enough. But I've put in 6 screws to be really extra on both sides. And then this is just chassis rail, because we're putting bearings on the edge and I didn't want to shave them down. So it's just chassis rail, and it's steel right now. If I can find aluminum chassis rails, I'll do it, or I'll just take 3 wide and cut down the bottom edge for 1 by for the top of the tower anyways. So that's that, and well, it spins on both sides. Yeah, that's it.